So I'm going to be discussing the need to account for the impacts of marine litter in life cycle assessment methodology. To give a sort of brief overview of what life cycle assessment is, it's a technique to assess the total environmental impacts of a product or service over its entire life cycle. So that's normally from raw material extraction through to disposal or recycling. And the overall goal of an LCA is basically to compare the full range of environmental effects of all the inputs and outputs into creating a product or a service and how these material flows affect the environment. So how does an LCA work? So you start by creating a life cycle inventory, or an LCI, which is a complete inventory of all the flows to and from nature that affect or are involved in a process. So that's water, energy, raw materials, and emissions. We then use that LCI and characterize each one of those flows. So basically it quantifies each one of those material flows, puts them into common units, and then sums them all together to create an overall sort of environmental impact or indicator. So that leads to what we have as midpoint categories first, which is the sort of direct impact of each material flow, which are things like land occupation, global warming, ozone layer depletion, things like that. And then from there you can create what we call endpoint categories or damage categories, which is a summation of those to create things like damage to human health and damage to ecosystems. LCA is used sort of quite extensively now in the sustainability sphere. It's often used to support business strategy, so a company can do what we call an organizational LCA, where it looks at their entire footprint, and then from that they can create a business and sustainability strategy to sort of manage their main environmental impacts. It's used a lot in R&D and product and process design, so if you're creating a product and you want to look at opportunities to lesser the environmental footprint, you can conduct an LCA and then look for supplementary or alternative materials. LCA is also used to identify environmental improvement opportunities. So because it's such a sort of detailed process, LCA can really kind of pull some things out that probably would otherwise go unnoticed. Education, so for customers as well as staff and sort of just for company transparency, you can do an LCA to let your customers and your staff know what your sort of major environmental impacts are and what you're doing to address those. Product declarations, so you have things like EPDs, which are third-party verified LCAs, used now a lot in industry rating tools like the Green Star rating tool and the IS rating tool, which companies can be given points in those rating tools if they use products that have EPDs. And then sort of most relevant here is for procurement. So we can do an LCA of a company's procurement processes and their supply chain and identify environmental hotspots and key issues there. So LCA it's holistic and it's quite scientifically rigorous, but there are some limitations. Firstly, you can have inaccurate or limited input and output flow data. You can have generic data, so if a product is made here in Australia but raw materials are imported from overseas, we have to use generic and industry average data for those raw material sourcing, which can sort of lead to some inaccurate reporting. Using different databases, so not all databases are complete, so we have to basically kind of pick and choose from different ones when we're conducting an LCA, and each database can use different processes for measuring material flows, so that can cause some differences. Similarly, when you're doing the assessment, you have inaccurate or different characterization factors. So the assessment method, which converts those flows into actual quantities and impacts, those can differ depending on the assessment type. And what I'm going to talk about here is the end-of-life impacts. So we've got really, really good data on impacts and material flows from landfill, recycling, incineration, and the sort of standard end-of-life options for materials, but if something is thrown away as litter, we have no way of quantifying that and using that in the LCA. So the graph here shows the sources of marine plastic pollution in Australia. So we do have a really good understanding of the composition of marine litter and where it's coming from and how it's moving around the globe through currents and through oceans and things like that. But again, we don't have a method of quantifying the impact it then has as it breaks down in the natural environment and the effect this has on ecosystems. So, we're aware of what's happening, but again, we can't quantify that into a usable data set. We also don't know the social and economic impacts of litter. So Australia's marine ecosystem is worth over $25 billion per year, and we don't really have a direct correlation or a really solid understanding of how marine litter can affect that. So again, we understand that marine plastic debris is a main driver of biodiversity loss by affecting biochemical cycles on seabeds. It leaches substances in the food chains. There's microplastics now being found in the fish we're eating. It can aid in invasive species travel, so as plastic doesn't break down as a normal biodegradable material, it can help invasive species travel between oceans. And affecting landscape value and revenue. So in developing countries, we're seeing this a lot, where really littered beaches and littered marine environments are affecting their tourism industry. But again, same issue. We know this is happening, but we don't have a way to quantify this and use it in LCA. So the issue is that it's really sort of undermining a lot of the work that councils and government bodies and even industry are putting into using LCA. So a good example of this is a case study we did at Edge comparing different serveware materials, so takeaway packaging. So we looked at paperboard, polystyrene, PET, and compostable packaging from cups, plates, containers, and things like that. And the goal of this study was to be used to inform policy and potentially procurement guidelines and requirements. Now, of those impact categories we looked at earlier, a lot of them were very important in this analysis, but litter control and the impact of litter and the likelihood of materials ending up as litter were also a really key factor that they wanted to look at. But because we don't really have this data, we sort of had to improvise, I guess. And so we came up with this sort of bespoke litter indicator that considered the tensile strength of a material, the time it takes to break down in the environment, and the likelihood of becoming litter, which we found by looking at production data and then litter composition analysis. It sort of came up with a factor there. But this sort of looked at, how the likelihood of something becoming litter and then how long it's going to be in the environment. But again, it doesn't consider the environmental, social, or economic consequences, and it lacked the scientific rigor of other indicators. So to use this as a basis to inform policy and procurement probably wouldn't stack up if that was the goal. And unfortunately, in this case, plastic often looks better than other materials because it's quite lightweight and there's not actually a lot of material in it. So for a polystyrene cup, for example, has about 5 grams of polystyrene in it, whereas a paper or a compostable cup will have sort of 2 to 3 times that. So this issue, everyone's kind of aware of it in the community. We know it's a problem. So there was an LCA conference in Medellin, Colombia, last year, which was a discussion about how the life cycle community can help contribute to the UN Sustainable Development Goals. And the declaration basically from the end of that conference was that LCA is one of the most widely used environmental sustainability assessment tools, and it's not adequately addressing the impacts generated due to marine debris, plastics, and microplastics. Indeed, there's still an overall need to assess marine ecological impacts in life cycle assessment in a meaningful way. So again, we're aware that this is a problem, but it's been a year since this declaration was made, and we haven't really seen any progress or any funding going towards solving this issue. So to sum it all up, I guess, this is just about generating awareness of the issue and a call to action for government and private industry to support further research to fill the knowledge and methodology gaps in order to inform better decision making with regards to litter. Thank you. Any questions?